Hope you have understood first in first out page replacement, least recently used, and optimal page replacement algorithm. So the fourth one is clock policy. The name is derived from the way we are going to utilize the page frame bit. So it is going like a circular queue. So it is named so. The clock policy uses an additional bit called use bit. So this use bit can be turned to be 1 and 0. So if you find it is set to be 1, it cannot be replaced. And if it is 0, then it can be replaced by, so it can be targeted. So by replacing the particular page which is residing in that frame can be replaced by new pages. So let's start with an example. So the same sequence of page address stream is used in the clock policy too. So here have a look. One more a special symbol is involved in the frame. I hope it is visible. The nearby numbers you can find a star symbol or asterisk symbol, and there is a one arrow mark too. So the star means the particular frame bit is set to 1. So you can't replace that page by new page. So that means the frame bit of that particular frame is set to 1. So that frame page cannot be replaced. And the arrow mark. The arrow mark is for marking if a page needs to be replaced or the new page which comes, it can accommodate in the place where it is pointing to. If it is find free, or either the frame which is pointed by that arrow mark has the bit 0, otherwise it will be moved to the next consecutive frame. So it will go on search where 0 appears. So let's start. So as I already told you that the first 3 place we are not going to mark it as a page fault. So 2, 3, say 2, as soon as the 2 is entered it is marked as a star, so which cannot be replaced. Next, immediately the arrow mark is moved one step down, so it is pointing to the second place. So here 3 comes, so 3 is placed over there and the arrow mark comes down, so in the next point it is pointing to the free space. Again 2 is referenced as it is already there, so there were no changes on even in the star and as well as in the arrow mark, still it is in the same position at this place. So now the reference string 1, so as 1 is entered it will be placed at the third place. So now up to this we have done it. So 1 is resides. So now what happens next is 5. Next reference string is of 5. Now the operating system, that is the clock policy, is going to find a room for 5. So now 2, 3 and 1 is in the main memory. So out of this the arrow is pointing to first position. So now it needs to find a place. So as it is pointing to number 2, it is star. So what happens? It is switching into 0, but which cannot replace. So after flipping this bit into 0, the arrow mark comes down. So the now the arrow mark is in search of frame where it can find 0, so it will come down. So now 3, so I'm going to draw here. So after this, here it is going to point here. So now what happens, it is moved into the next position. So now the bit becomes 0 here, right, the place where the number is 2. Then number 3. So even here the bit is star, so it is changing it into 0, then it is moved into next position. So there the page number 1 resides, but there too the use bit is of 1, so again it is flipping into 0. So after completing this, the arrow mark again goes back to this place. So now it is 0. So now as it is 0, it is this is the place targeted for to replace new page. So you can make a note at this point of a frame, the 5 is accommodated in the very first place. So hope you have understood at this point. So now I will clear out all this writing. So now say here we have got a room for 5, and which is replacing 2 by 5. So a page fault occurred successfully, we have changed. So after placing 5, you can find that the arrow mark is moved into the position 3. Now the use bit of frame number 2 and 3, that is the page 3 and where the page 1 is available, you can see that there is no star, which means that in the earlier step, while searching for a room for 5, all the bit 1 is turned to be 0. So after completing a circle, it finds a room at the top, so that all these two were 0. So now next is number 2. As number 2 is not there in the main memory, now the arrow marker is pointing to 3. The use bit of that particular frame is 0, so the 2 can be directly accommodated into this place. So now the arrow markers moved to down, that is it is pointing to the third place. Then 4. So the same way like earlier step, the 4 is accommodated into the third place as the arrow mark is pointing to 1 and the use bit of that frame is 0, so the 4 can be accommodated over here. Then the arrow markers moved to the first position. So now have a look at this point. At this point it is same as like of here, these two are same, right? It is nothing but again we are going to have the same kind of step. So now a page fault, right? So now what happens, now the arrow marker is pointing into 524. So let me draw the same thing once again. So now, so at this time I can even write numbers too, right? So now it is 5 2 and 4, sorry. So let me draw it once again. 5 2 4. So I'm going to have this bit in star. So now all are star. So this is what the structure now. So now we wanted to make a room for number 3. So now 5 to 4 and all of this frame bits are star, which means that it is 1. So now what happens, while search of room for this, now I am going to make this bit as a 0 by highlighting it into yellow. So now the place where 5 is there, it as the bit is 1, it cannot, so this is going to turn into 0. So the arrow is going to come over here, then this is making it 0, then again the arrow mark is moved over here and it is marking it as a 0, then again it's come back to the first position. So after coming through all of these numbers, again coming back to the same position, it finds that it is 0, right? So as it is finding it as 0, now at this point have a look, the 3 search we are in the search of to finding a room for 3, so the number 3 will be accommodated into the place where the 5 was, so 3 comes over here. So hope you understood. So this is the point where we have accommodated 3. So now 2 and 4, say the bit 2 and 4 here are 0. So now if any future page fault occurs, which can be accommodated into the next two places. So next is 2. So see, you have to make a note over here too. Say at this point, though the arrow marker is pointing to 2, then 2 is referenced once again. So due to which the use bit of that particular frame is turned to be again 1 because it is utilized just now. So the use bit become 1. Then it goes for, say, after even after making it 1, the arrow mark is still in the same position because there were no page replacement is occurred. So the arrow mark is moved into the next position only if it accommodates a new page. So in the next step, see, there is a page reference 5. So if 5 comes, it will look for a replacement because 5 is not there in the main memory. Now the arrow mark, say in the previous step, let's see, the arrow mark is pointing to 2 and the use bit is of 1. So while in the search of room for it, it will become 0. So in the next step where exactly the 5 is present, it turned to be 0. So that's why it is highlighted in the blue color. Then it is moved into next place 4. So it is 0. So the 5 is placed at the third position, right? So after placing it over here, the arrow markers moved back to the first position. Say here, I'm talking about this position, right? Then the arrow markers moved into the first position. Then to its reference, it is already there. So it is marked as the use bit is marked as 1. Say the previous step 2 has 0, it is highlighted in blue. In the last step, it become 1, but still the arrow mark is the same position as there is no page replacement is occurred. So I hope now you have understood, but still you can go for practicing. As I said that you can assume number of frames are 4. Let you practice the same sequence of page addresses, right, and will help you to understand better. So here is the pictorial diagram for to show you how exactly this clock policy works. So now the arrow marks points to the place where a page replacement can happen. So the use bit and the page number and the frame number. So the outer side circle 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, then n minus 1. This is frame numbers, and within that box you can find that the page numbers, the pages which is accommodated in that frame, which has a page number and use bit. So with the help of this use bit, we can find that whether this particular frame can be replaced by a new page or not. So now the arrow marker is pointing to the frame number 2, which has page number 45, and the use bit is 1. So in this case, if a new page comes, this particular frame 2 cannot be replaced by a new page, so which needs to move down 191, and even here it is 1, but it will turn. Say whenever it is in search for a room, it turns the bit into 0. As it is 1, it will become 0, then next 191 use bit is 1, so even it will become 0. Then page number 550, that is frame number 4, the use bit is here. So if any new page needs a room, obviously the frame number 4, which has the page number 556, will be targeted for replacement. So let's see, here it is showing. So you need to compare both of these slides. So this is the initial position. So let you assume page 724 is referenced by the CPU, as it is not in the memory, so which needs to make a room. So what happens now, the arrow marker is going to search a room. So as the use bit of the frame number 2 is 1, it cannot be, so it will mark this as a 0 and it moves into the next position. Frame number 3, it has a page number 191, but the use bit of that frame is 1, so even it cannot be replaced. So this will change, that is flipping this bit to 0. Then the arrow mark moves into the page number frame number 4, which has the page number 556, and the use bit is 0, so it is targeted. So what happens after happening all this? See, the page number 556, the frame number 4 is replaced by the new page number 727, and make a note of it. Page frame number 2 and frame number 3, see, make a note, use bit of both of this frame is turned to be 0. So while in the search of room, the arrow marks moves into one frame to another, while finding the use bit is when it turns it to 0. Then where exactly it finds the use bit is 0, there it replaces the new page, then it is moved into the next page. Say, so after placing the 727, the arrow mark is pointing to the frame number 5, and which has the page number 13, and the use bit is 0. So in future, if any new page comes, a page fault occurs, immediately that page will be replaced by the page will replaces page number 3 and the frame number 5. So this is combined examples. So have a look, and as well I request you all to practice this by assuming the number of frames in the main memory is 4, and let you solve this to understand better. And if you have any doubts at any point, you may post in the comment section of our Google Classroom.